Okay? So, at the PCT, we're going to see substances get returned, okay? Then we're going to have it move forward. So, this process of reabsorption, I want to get back the water and the solutes that have made it into the filtrate and return it to the blood. There are two ways that this can happen based on the cellular structure that's present. The first way can be transcellular. Trans, across the cell. Paracellular, around, that means between the cells. So based on the tubular structure and its connection to blood vessels, if something is going to move transcellular, this means materials get to move across the cell because the cells are only one cell layer thick. Okay? So, take a peek at our picture here. Transcellular. All right, let me think about that for a second. Paracellular. Between. Here's the cool thing about the movement of some of these materials. They do solvent drag. So, as water moves through this structure, certain substances follow. Salts, our electrolytes, a lot of our nitrogen waste follow the water. So if the water can move, so do those chemicals. So if we take a peek right here, do you guys remember peritubular capillaries? We had on the cortical a huge capillary structure around that glomerulus. Juxtamedullary, we had a huge structure around the loop. Okay? Does everybody remember that for the structure? So here's what we're going to see. Here's my cell, my nucleus, blah, blah, blah. Here's my tubular fluid. This is my filtrate. This is what has entered this PCT from the glomerulus. In this tubular fluid, let's check and see what type of stuff is present. I have glucose. I have sodiums, I have chlorines, I have water, urea, uric acid, potassium, magnesiums, calciums, phosphate. Wait a minute. Sodiums, potassiums, chlorines, water, magnesiums, calcium, phosphorus. Do I need those materials to make their way continuously through the tubes to the collecting duct and out the body? No. I need them to return. Especially, for example, like glucose. Glucose comes out of the urine. That's an indications of diabetes. So let's kind of just look real quick at the glucose molecule. being represented. They're trying to show glucose. What can you kind of see? I don't know how good it is back there, but can you kind of see what glucose might follow?
Sodium.
Sodium. So, if glucose and sodium make it across, okay, we're going to see that it will follow other stuff, like we've got sodiums, we've got chlorines, we've got our glucoses. They're going to actually leave my tubular fluid and make their way back to the bloodstream.
Now, is this saying that nitrogenous wastes also make it back to the bloodstream?
They can make it back to those capillaries that will be around the nephron, but as we continue going through the loop, they'll come back based upon movement of the water and the salts and the salinity that gets created in the medulla. So, how is this going to work? Glucose makes it back, for example, to the bloodstream. Continues back because it doesn't move any other way. All right? It's not going to worry about trying to re-enter the tubes. Some of these other electrolytes will. Glucose continues back to the bloodstream, goes back to be used in the body. Of these, once we want to go out, we want our nitrogenous waste to leave. Does everybody follow me? I want my other electrolytes to move. So I've got my sodiums, my potassiums, my chlorines, magnesiums, calciums, phosphates. I want them all to go back to the body. Is that correct? But I want stuff such as my urea and my uric acid to leave. So, wonder what's going to happen with that. So at the point that I'm done with my PCT, the PCT has allowed for a lot of this material to return to the body. Yes, even including some of the waste. But I need that waste to come back to the kidney tubes and go out. So as we continue, what we're going to see, each nephron has a limit to what it can move. So basically, if it reaches a maximum, what they call the transport maximum, okay, basically any type of protein in the cell's membrane working to move stuff, it will simply say, I can't move anymore, so you've just got to continue. I can't do, this is all I can do. Good example, glucose. We know that in the case of diabetes, with diabetes, the glucose is not getting utilized correctly. It is not making its way into the cells of the body. So a lot of it makes it into the filtrate. The nephrons can only handle so much of it. And at that point, it continues through the tubular system. And because there is no other point except for the proximal convoluted tubule, there is no other point that glucose can move. Glucose only moves out at the proximal convoluted tubule. So, if it doesn't move, it continues its path, it makes its way to the collecting duct, into our calyces, into the ureter, and out by way of the urine. Diabetes.
Can glucose absorption be regulated by regulating your sodium intake, since they follow each other?
Now, don't quote me, but I do know that in type 2 diabetes, which is the one that's based on lifestyle, that you can affect its movement based on diet, okay? I'm trying to think if one of the things that they focus on for a diabetic diet is salt. And I'm going to have to look that up. But, yes, you actually affect its movement. So I'm wondering if it is. That's a good question. Well, I guess I've always thought about it, and actually a doctor I was talking to a couple of weeks ago, he gave like this whole, I was like, can you please come discuss this in my class? I was like, because there's no way I can teach it the way you just taught it to me. A lot of what happens with diabetes is the fact that it's vascular because of the way that the glucose is moving through.
Small blood vessels in the body.
Yeah.
Like the capillaries where the absorption takes place.
And makes it like, to retain the fluid and that sort of stuff. And so I will look up to see, but I do know that the diet, like on the diet, you focus on eating less fat and less sugar and that sort of thing.
But if you do that and also regulate sodium intake, so you may limit sugar, but you also want to make sure that you have proper levels of both so that you're getting them.
And the body's using the salt correctly.
Yeah, so the transport.
And then the glucose is following. Yeah. So in my mind, that's what I've got going in my mind right now, is that. But don't quote me on it. So this will be an area of the body highly affected by diabetes. Okay? Diabetes is just all over the body.
That's why one of the symptoms of being a diabetic is high urine output.
Because the way they used to test for it, somebody had to taste your urine.
Oof.
Yeah. I know. Well, and think about it. It was probably the doctor, and you got to remember back in the early days before we had tests for diabetes, even had treatment for it and so forth. I mean, the symptoms and stuff were still present. Okay? But it was like treatment. There wasn't a lot that could be done at that time. And yeah, so early on, before we had actual tests and everything for it, the way that it tested people for it was somebody tasted the urine. Now, reabsorption. But now, wait a minute. What is this process of secretion? In my mind, secretion would be, all right, if I'm looking at my tubular system, then the cells would be secreting something. That's in my mind, okay? It's opposite. It's going to be those blood vessels secreting back. Okay? So, we're going to see that this, I got a renal, that should be renal, okay? The tubule extracts chemicals from the capillaries. Because, wait a minute, on the previous slide,